Hello, everybody, and welcome to our panel, the Utility Data Access Revolution. This revolution will not be televised. It will be transmitted via smart meter. And so first, I'm going to go and give you a little overview of the status of smart meter deployments, the ways of getting data out of a smart meter, and then the rest of our panelists will speak. So yeah, let me dive right into it because I know we're pressing up against time here. So first, we'll discuss a little bit about how smart meter data access is going to change the game and turn consumers into prosumers. I think that's noise from next doors, right? Yeah. And so Prosumer is my favorite minimal techno DJ from Berlin. But prosumers are also consumers who are professional in that they are on top of their consumption and really looking at how they are consuming a service like energy or water, for example. So then we're going to discuss briefly how you can practically get data out of a smart meter, look at how meters are deployed across the world and specifically in the US, and the data access that you can get of the smart meters that are deployed. And we'll briefly discuss how policy making plays into this, because there is no data access without there being policy that tells utilities to give data access. And then I'll briefly touch on why I think having data access is going to revolutionize the energy landscape. So here, this graph shows us, this is from a review of several different papers that study the impact of energy consumption feedback on residential consumption. Later on, John and Jim are going to speak more about the industrial setting, but so this applies to residents. And we see from anywhere from about 4% in giving people some more information on their bill, to 12% when people actually have real-time access to their data. And then the 35% is realized, and this is actually from a paper by Faraki, who you might have heard of. He's a leading economist on time of use rates. And he finds that the 35% reduction is only realized with time of use rates and critical peak pricing if customers also actually are aware how much they are using. And so that's the difference between indirect feedback, direct feedback with real-time access, and then having the real-time access and being given insights further into usage, using smart thermostats, connecting other devices into home to smart meter information. So this diagram here shows from left to right are different options for getting access to utility data, and from left to right in granularity and effectiveness. So all the way on the left there, we have our monthly utility bill. Who here in the room actually reads their utility bill every month? Okay, doing pretty good, but you're engineers, so that's to be expected. And who here can get access to data from their meter? Okay, it's a lot less, but I know you're special, and yeah. So that's rare still also. It's okay if you don't look at your bill. It's really normal. It's something that's in the industry called rational inattentiveness. Otherwise, you don't care. That's basically what that means. And that is because your energy doesn't cost so much, not enough for you to care enough to open the bill. So something else, it needs to be something else that engages you to do that. So the next step is a customer authorization form. And engineers in the room here may have had to deal with this. This is where you get sometimes even a paper form that's submitted to the utility company that has a signature of a customer that says, yes, this service provider can get access to my data. And then the utility shares it in a CSV or maybe a big stack of paper bills that happens too. And then the service provider has to claw their way through that data. And one of the big disadvantages of that is that every time you need to do analysis and get current data, you need to repeat that process of getting authorization from a customer and then getting data from the utility. That costs a lot of money. And every utility makes the data available in a different format, so that takes work as well. So next is Green Button Download My Data. Don Coffin from the Green Button Alliance is here to give us a deep dive into what Green Button actually is. Here, Download My Data is a download of a standard format of usage data from your utility's website. Again, there's a disadvantage there if, as a service provider, you have to ask your customer to go log into their utility website and then download a file. So there's some obstacles there. Then the next step would be Green Button Connect My Data. That's the same standardized energy data, but then serves as a web service. So third parties can connect their apps to an API that the utility company has, and they get to pull data straight away from that. The next step in granularity is what it says HAN, that stands for Home Area Network. Could also be a BON, a Business Area Network. And this is where customers can get a hub, a Zigbee hub, that talks directly to the meter and gets readings from the meter down to 8 seconds. Apparently, if you do it more than 8 seconds, the utility sees it as a DNS attack and communications are shut off. So 8 seconds is where we can go right now. And that's a hardware limitation. So in addition to going from granularity, a lot of very little granularity to great granularity, very little effectiveness to great effectiveness, you could also say that there's from left to right, great latency and impedance in the monthly utility bills and authorization forms, and much less so in getting web service access to data or connecting straight to your meter with a hub. So here, this diagram shows those kind of two hipper options of getting a more continuous feed of data. The gray box over here, this is the home's Wi-Fi network, so that could also be a business if you have a commercial customer. And so there we've got our smart meter and our Zigbee hub that talks straight to the meter and connects to the internet router. Sometimes that can also then send information to the cloud and to third-party applications and to devices in the home. So for example, if you want to do laundry and you want to know if you want to make sure that you don't go over a certain amount of demand, your laundry machine could say, hey, maybe it's better to postpone this for a little bit. Or it could turn itself on when it's time to and the rates are lowest. And then the other way is this Connect My Data. That's what is called backhauled through the utility. So the utility gets the data from the meter, the same platform that they do for billing you. And then they set up a web service, and third-party applications can pull it straight from the utility through the cloud. And so that data is often made available with a delay as well, because the utility says we have to do a lot of validation on it. So that's also reporting after the fact, while the access with the HAN gateway is in real time. I do want to mention there are some utilities that are trying to offer real-time access to data so that you don't need any hardware at all. So in any situation, let's say you get a new customer, they have a smart meter and their utility gives you real-time access to their data. No need to install any hardware to get that really detailed level of data. Again, a utility makes decisions in how granular the data is, because it could be 15 minutes, it could be 1 minute. There's differences, big differences there as well. So here's a little bit of an explanation of how Green Button Connect work. I'll let Don explain this further. But basically, we've got the utility is serving as a web service provider there. A third party can get registered with the utility to receive the data, and they're authorized by the customer either through a web portal from the utility, or when they're logged on to the third party's software application, they could do a single sign-on. You know how you can get, you can log into your bank account through, say, an application like Mint, and then pull data through there. You don't need to separately go to your bank account and say, hey, give Mint access. Kind of works like that. So yeah, and so as long as the user or the agent here, that the customer gives access, gives authorization, then from there on, the feed of data can be continuous. So that means that we don't need to repeat this process over and over. If somebody is a customer and say you're doing a retrofit and you want to do before and after analysis, given the same way of measuring that, their usage. So this is a diagram of the multiple integrated circuits in a typical smart meter. And here in the middle, the green boxes, that's the work that the smart meter is doing, the metrology tables. This here is the neighborhood area network. That is what the way that the utility is getting data from smart meters. So that can be through a power line connection, GSM network, or they can have their own wireless network set up. And the way this can often work is that the meters talk to each other in a mesh network. And so your data is hopping from one meter to another to the utility. Then under that here we have the home area network communications, and we could see that's a completely separate gateway from the utility's way of accessing the meter data. And there are reasons for that, obviously, security reasons. Important to note here is that these arrows go both ways. So the utility can also push data to the meter, pricing information, for example, which you could then get in real time. So if we're talking about a laundry machine that's going to decide when it's going to do the laundry, it would want both the pricing signal and your current load. So this is, I'm not going to dive more deeply into that. I'm not a smart meter manufacturer. If you have more questions, I'm happy to refer you to people who are. So once you get really detailed data, down to 8 seconds even, you can do something called non-intrusive load monitoring. Who here in the room has worked with non-intrusive load monitoring? Yep. So how that works is, this is a very simplified graph from George Hart, who in 1992 kind of developed the concept of this. And here we have on our y-axis the kW power and time on our x-axis. And the non-intrusive load monitoring picks up signatures of devices because it recognizes how they turn on and off, how they cycle. And so this has been in development over the last year. Since 1992, a lot has happened. There's some constraints on smart meters, like I said, in terms of the granularity of data that you can get. To do non-intrusive load monitoring, you would ideally have lower than 8-second data, so 1 second or millisecond data. You would also get harmonics and power quality, and all those things together would give you an idea of, it would give you a better opportunity to disaggregate. But now there's a solution similar to how speech recognition software has developed that got a lot better because Google and Apple got a lot of samples of your voices from Siri and from Google Voice. And this is how they're now better able to quickly recognize what's happening. And the same is happening in non-intrusive load monitoring. There are companies that have set up large libraries of different devices and their signatures so that then when they pick up new data from you, they can quickly say, oh, that's a fan, oh, that's a heater. And so how this works, why it's interesting to pick up these signatures is, let's say your system knows you're not home and there's a heater that just kicked on. Well, obviously that should be shut off. So the idea is that it's similar to an energy management system in an industrial facility, but then in somebody's home. You could have what they call a home energy management system. So not EMS, but a HEMS. So that's really quickly how you can get data from smart meters and what you could do with it. Here we see smart meter deployments across the world. This is a little bit of an older map. There are about 700 million smart meters currently deployed. Over half of them are in China. That's how we know that this map is not that great. But I wanted to show it to you because this actually shows both AMI, Advanced Metering Infrastructure, and AMR, Automated Meter Reading. And there's a difference between the two because just reading the meter is really handy for the utility, but what the infrastructure part of really offers is a two-way communication where the utility can send signals to the meter, like pricing, like I mentioned, or demand response signals, for example. So that really changes the game. And as well, like I said, the smart meters actually give customers opportunity as well to connect to them real time. So let's focus on the US, because that's where we are. This is some data from the Energy Information Administration from 2015. And these are all the meters, the percentage of meters that are read automatically. So that's both the AMR type meter and the AMI type meter. It's a pretty nice dark map, I would say. We have about 150 million meters deployed in total. Of that, there are only about 40 that were traditional meters in 2015. So that's pretty good penetration. But then if we look at how many of those are actual smart meters, that map is a lot lighter. Yeah. So there were about 65 million smart meters in 2015. And it's projected that that will grow to 90 million in 2020. So that's looking pretty good. So we've got a lot of smart meters already deployed. That's great. Now let's see how much customers can actually get data from those smart meters. That's, again, a bit of a lighter map than we saw before. So I called up the Energy Information Administration. I asked them what daily digital access means. They couldn't really tell me, so they went ahead and looked it up. And it can mean anything in terms of, it could be green button data, it could be people logging on to their utility website, really anything. So we've got to take this data with a grain of salt here. Does it mean that they have machine readable data? And then the next map here shows, of those smart meters, for which ones can you actually connect a hub to the smart meter to get data in real time? And that map is a lot emptier even, as you can see. Now, we don't know how much we actually should trust this data from the Energy Information Administration, because we know for a fact that California had more than 10% meters with HON radios that were enabled. But it gives you an image. The map goes from really dark to a lot lighter when you really look at what customers can actually get out of those meters. So again, here's some key stats, about 700 million meters in total. So that the number that the EIA says had HON access is 6.6 million and 90 million by 2020. So that's there's still a little bit of room for growth there. What's happening is that utilities who currently have the older AMR type meter are kind of waiting for their end of life because they have a hard time justifying why they would switch to this other type of, supposedly the main reason to switch to an AMI meter is also to be able to read it automatically. They can already read automatically. There are other reasons to switch, especially in states where they're trying to reduce peak demand, and this kind of real-time access is really important, but that's slow going. There was a significant grant project under the Obama administration, the Smart Grid Investment Program. Unfortunately, it seems that funding has dried up for that program. But right now, for example, in New York, we do have some, we'll get to that later, we have some smart meter implementations going on. So how does that happen? How does it actually happen that a utility starts to give access to their meters? Because it doesn't seem like it's automatically happening. And they put in place a lot of smart meters, and they derive a lot of benefit in being able to more efficiently where the energy is going and plan ahead. But they haven't yet fully realized the benefit of the smart meters on the demand side. And what you need for that is data access. So the way that happens is through public service commissions who tell investor-owned utilities what to do as part of a rate case proceeding. So the utility goes, hey, I want to install all these smart meters, and then the regulator goes, that's great, but you have to give your customers access. So that hasn't happened with the prior implementations, obviously. That's now changing. One of the organizations working on that I work with is called Mission Data. And this is a tweet that they put out where in Michigan, where there's currently an ongoing proceeding about giving customers better access to their data. And so their mission data is then representing energy management companies, probably like yours, and trying to work with the people at the Michigan Public Service Commission staff to better understand how important this is and to make sure that it gets written into orders in a very concrete way. So these currently are states in which mission data is active. California is definitely ahead of the pack in terms of data access, where customers for the major utilities both have Green Button Connect access, and they also can get a direct connection to their meter through the home area network. Texas was actually really early on already active in this. It was deregulated early. They had a common platform for people to access their data, but it wasn't super well managed and not very accessible to people. So now again in Texas, there's actually some new utilities putting in smart meters, but they're trying to get a waiver to not have to give customers access to the data, which seems silly, right? Yeah, I think it's silly too. But so Mission Data is working with the commission there again to make sure that that doesn't happen. So the process of going through Public Service Commission proceedings is really time-consuming. This is the New York State document management system where I've spent some time, and I know some people in the room who have as well, but it's noble work. So in New York, we've been actually really successful in working with the commission, and together with the deployment of 8.5 million smart meters, all the utilities in New York are also going to give customers access to Green Button data as well. They haven't yet talked enough about enabling radios as well, but at least they're going to get Green Button access. So some of the roadblocks in making this happen is privacy rules. It's always the first thing that comes up. There are actually privacy rules that nationally govern access to data, but utility commissions are afraid, and they want to make sure that they address all the concerns. So that could be one of the roadblocks in the privacy regulations and have to precede data access regulations. There aren't yet fully established protocols for some types of data, like tariff data is what you would need to be able to not just tell customers how much they're using, but what it's costing right now. So a tariff usually right now means like a big PDF that you have to go dig in and be a specialist like Mr. Onnen over here, who has lots of experience in doing that. Then different people need different kinds of data. Demand response companies, for example, need something different than an energy analysis company. I skipped here the lack of technical background among stakeholders, also a big problem. Takes organizations and people like me to help educate the regulators on, what a web service is. It's different than a website, and radio in a meter. How does that work? And it's important for them to understand. Oh yeah, and the collaboration between utility companies also big, because in one state you wouldn't want to have 5 different ways of accessing data. That all needs to be the same. So utility companies need to work together to make that happen. So why is this a revolution? Right now, if you want to do energy analysis, you still have to work yourself through a big stack of bills. And once this is all in place, and we've done the work with the service commissions to get utilities to make data available, it can happen with a few clicks. And that really changes the game in terms of how you can service your customers, what it costs to do that, the time between when you launch a new customer, and you can give them some insights. So I call it a revolution because of that. Okay, that finishes my talk. Do you have any questions?